Well, hi, and thanks so much for joining me here in my shop. On the last video on this radio, I was all wound up to demonstrate and investigate the image rejection factors around this radio, and I got within pretty close to doing it when the radio itself broke down. So I'm looking at a radio that broke down, and I don't know why, so I'm going to find out why now, or what has happened to it now. One observation I did manage to make. Okay, so when it broke down, it was playing normally. There was a bit of a pop out of the speaker, and then the hiss level went way up. I tuned it. Didn't seem to be responding, but it's hard to know because this hiss level was quite high. Could have been stuff happening under the hiss I couldn't hear. Seemed to me the radio at one spot seemed to be breaking through a little bit. I noticed the volume control, you turn it up, turn it down, the hiss remains with the volume turned down. All that stuff makes me think something happened in the audio circuits or the detector. The first thing I would be suspicious of is the detector tube, mostly because it's a pretty easy thing to settle. I'm going to get another one of those tubes, the detector tube in here is a 12 SQ7. So I'm going to grab one. We're just going to switch it and see what happens. I don't have one in here, I don't think. No. Okay, I have to go fetch one. Okay, let's carry on here. So I have a replacement 12 SQ7. I'm going to turn on the radio, see the problem, hear the problem, switch the tube and see what happens. Hear the problem, see the problem. Now if the problem doesn't reoccur, oh my gosh, it's gone away. Oh, what do we do now? What do we do now? So it may be a heat-related problem that doesn't show up until the radio really warms up after an hour or so. Well, I should get back to what I was doing. I want to just get back to the experiments around image rejection, image reception, and the like. Because I can't do anything with it like this. It's working. Hey, it doesn't work when you want it. It works when you don't want it. There's just nothing here to... Just nothing here. Okay, so I gotta set the whole thing back up now to carry on. But I'm gonna keep that spare tube you see over there. I'm gonna keep that handy. I'll get everything set up and we'll carry on with the image investigation. Okay, so radio's still fine. So that's 590, but I want to do my little experiment at 600. So I want to tune this to 600 exactly. So to do that, I'm going to use the signal generator. We'll set the signal generator to 600. So now there's a 600 kilohertz signal on the end of this wire. Oh, what was that? That was ugly. That was pretty ugly. I don't know. This guy's gonna break down again. Okay, carry on while we can. So we get the 600. Just gonna clip it on the insulation of the antenna. Hopefully there's enough signal. You should be able to hear the 600 right around here. There it is. So the radio is tuned now to 600, and we should see the local oscillator. Oh, I didn't hook that back up. Hold on. Easy to do. Easy to do. It says, where's my little coil of wire? Oh, 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 oh. I don't think we're going to get too far here. That was quite a strong thunk there. Oh boy. Carry on, man. While we can. Get done what you can. Okay, I can't find my little yellow coil. I'm all panicky now. Make this into a dumb little coil here. Kind of stick it over here. That didn't work out. It's not the best coil. Just sit there. That's probably enough though. So looking at the SDR, you see the tuning is 1055. You see the red line and this peak right on. That's the local oscillator there. Radio, hang on. So now we want to find out if don't go away, don't go away yet. 1510. Tune the signal generator to 1510 very quickly. Will it show up? 1510. Come on, let's get moving here. 1510. Here we go. Okay, so now I have the output of the signal generator connected just loosely like this. I'm going to connect it more. Just get the end of the antenna wire here right to it, but no ground on. No ground from the signal generator yet. Okay, the radio went quiet. There it is. So there we are. So what we've discovered is that when this radio is tuned to 600, and while it continues to work, hang in there, baby. What is it? What is it? Quick. Seems like something electrical. Breaking down. And she's gone away. Oh, come back again. Wow. What? Oh boy, this is a good opportunity here. Abandon the experiment. Everybody, shift gears now. Oh my gosh. Nah, I didn't want that to happen. Gone quiet already. Get the stick. Where's the magic stick? This stick, I've had more luck with this stick than almost any other troubleshooting technique. I think it's in the audio circuits. Right there. Here. This is one of the output tubes. It's a resistor that if I tap it, it's very, very sensitive. Because the tube's not plugged in very well. Over here. It's the same resistor on the other output tube. Of course, nothing. I think it's this capacitor. It's really loud. I tap this. Nobody else is musical. That's coming right out of the speaker. Oh. Doesn't get any louder with the volume. It's past the volume. Okay, let's go after that capacitor. I think that's the guy. I think that's the guy. This is the best troubleshooting thing I've got in my shop. Beats all those instruments to death. Literally. Really, the amount of success I've had with a stick, not just here on my videos, but throughout my life and over the years. Maybe I should manufacture these and sell them as troubleshooting tools. Okay, so I may be excited about nothing, but let's go after that capacitor. Now when I was tapping it and you could hear it come out of the speakers, I had a friend of mine demonstrate with an audio cable. This is not an audio cable, but with an audio, just an ordinary audio, phono type cable, a cheaper one. He had plugged into a stereo. He just took the wire and tapped it. I mean, you could hear that come out the speaker. Hitting the wire, come out the speaker. I couldn't believe it. And he switched to another wire and said, tap it, nothing. Amazing, isn't it? So amazing. Now, let's see if I can remember which capacitor it is. I'm so excited about my stick success. Power's off, yeah. Maybe one by one I am changing all these old capacitors here. So this capacitor, when you look at it, the wax is not uniform on it anymore. It's pretty dry up in this end. You can actually see the, you see how this is kind of bulbous here? Kind of covered nicely, but this is not. Well, we'll give him a test in a minute. What is he? What 0.01. Okay, 0.01. 0.01. I cut them out and I make a note of which way which end the outside foil was on. Where'd this come from again? Up here. Oh, it was this way. I remember it was this way. So outside foil down to this terminal here. Okay, I've marked the outside foil on my own capacitor. You can see a little tiny dot. Can't really see it there. Too much light for the camera. So I'm going to put this capacitor in, then we're going to run this radio, then we're going to do what we intended to do right from the start. Sure. Okay, let's give this capacitor I took out a test. Now, if this thing's breaking down and it needs to warm up or something like that, I mean, we may not see anything on this test. Maybe we'll break it down on this test. Okay. There we go. Now you can see the open area on the magic eye here. We're on the 50 volt setting. What's it going to do? So it's opened up halfway. So this indicates the resistors or capacitors, relatively speaking, it's not the worst capacitor in the world, but most can withstand 50 volts fairly well. 150 and it's not going to open. It's a very leaky capacitor. Now, is it in its bad state, or is this in the good state? And it was popping into an even worse state. Well, I really can't know from doing this test. But certainly it's leaky. That's the third paper capacitor I've tested, and they're all coming out kind of similar. You know, a little leaky, but not at the end of their life, unless they're in a very sensitive location. So if we think about the other one I replaced up here, that tested kind of okay. I mean, it wasn't screaming out, I'm a really bad capacitor, yet replacing it had a big effect on this radio. So maybe I'm going to end up replacing more and more of these as we go along. That's kind of the idea anyway. So, not to shotgun them, but to do it with wisdom and a sense of peace. Okay. Where am I at now with this guy? So I'm right back to where I was again. Right back to where I was again. There's a statement. Maybe I should have been a salesman. If I can come up with strong sounding statements that actually mean nothing and commit nobody. Now, power this guy up again. Make sure it's on 600. We actually picked up the we picked that up. Now we picked up the image signal, so we detected the sensitivity. It's there. Kind of surprising to me in a way, but it is. Now I'm putting in a really strong signal. I got to think about this before I do the next stage. I'm putting in an awfully strong signal over here. We just kind of get a notion of how much it is. It's 10,000 times 10 microvolts. So that's 100,000 microvolts. That's 0.1 volts, I think, if I got it right. That's a very strong signal. Could you ever have a signal at the image location that could put 0.1 volts onto this antenna? Probably not. But see, the image situation with this radio isn't the same as with other radios that are much, much more sensitive. So this guy's, his job is just to pick up fairly strong broadcast signals that people can listen to pleasantly. He's not intended for hunting down weak signals and stuff like that. So the need for this radio to have excellent image rejection isn't all that great. Let's see, 1504 is what I've got up here. I think it was 1510. Let's look on the SDR and just see what kind of stuff is floating around in my shop at 1510. As soon as I get entangled here. Yikes. Okay, let's just take a look at the SDR here. So for an antenna, I've got nothing here, it's shorted. I'm going to open it up. There we go. So it's just a very short little piece of wire antenna laying on my bench. And all these things I'm pretty sure can be considered noise signals. Let's listen to a few of them. Not much to hear. There we are. So in my house at 1400 kilohertz, there's a powerful noise signal here in my shop anyway. If we had this radio tuned such that the image sensitivity spot was here, 1400, this would come out the speaker. Almost, well, it's going to be, you know, we're hearing it loud, we're hearing it full through the radio here. Through the radio I'm working on, it would be suppressed because the radio is actually tuned, we'd be tuned way down here. Can you even get this? So let's see, at the very bottom, let's use 500 because it's easier to calculate. Suppose we have the radio tuned to 500. So the local oscillator would be at 455, be at 955. Well, that's only here. So that means noises all the way from here up can cause this image problem. And all the way up into here. So the one we're really interested in now is around 15, oh, it's 1504? I thought it was 18 something. Where'd my little note page go? 1510. Well, 1510 is right. Look at that. There's a whopper of a noise signal there. 1505 has that huge thing. What's 1510 look like? Just off the noise. So that means as I tune the radio downwards from where it is now at 600, this noise signal is going to enter the, air quotes around it, image slot. And that's pretty much going to be just as I'm tuning in 590, which is an actual signal. So now if 590 is strong enough, I mean, look, here it is. There's 590 right there. Okay. I don't have enough of an antenna to pick it up. There we go. Okay, so what I did there was I grabbed the antenna with my hand and I became part of the antenna. So we're on 590 now. So in that other radio, at this point, 590 may also be picking up that strong signal at wherever it was. I can't remember where it was. Let's go check it out. So this is a little tricky now. Well, I got to turn off this other radio. Just a sec here. At least turn the sound off from it. Oh, I don't have this guy on. Okay, switch him on. So our thinking now is it's tuned to 600. We know it's sensitive to some degree to image signals. We know there's an image signal that the radio will pick up at 590 or so, somewhere up here. And also there's the strongest AM signal kicking around here. So we're going to try to hear the AM radio signal and become aware of the image noise interference thing that might be happening with it. That's kind of the idea. There's all kinds of weird interference here. So the antenna itself, it's just this wire. You see me throwing around. Just going to throw it on the floor here. There she is on the floor, next to the ground. So tune down a little bit and we're going to pick up 590. So there's noise. Now is that noise because there's noise here? Or is that noise because there's noise up here? So you can hear some heterodyne tone in there, obviously from a noise signal. Is that heterodyne tone because of noise landing right on 590 from up here? I don't think so myself. I think all we're hearing are noises that are right around the station down here. I don't think we're hearing the image. I think we heard the image because I piled a whopper of a signal into this radio. So we'll get the we'll tune the image in here, and we'll try to figure out how strong this has to be to be heard on the radio. So we'll go back to 590 here. So I think that's 590. So we'll carry on here. So I think that's 600 now, roughly. Maybe not. I hooked my signal generator straight into the antenna again. I think that's the only way I got this to actually show up last time. Boy, doesn't that make it quiet. Clean that guy. 1510. It's there. Oh yeah, I weakened the signal. Now you can hear it. I'm just listening. I'm just listening to what it's doing. I think I've got two frequencies just a couple cycles apart here. It's doing that. So tune in 590 and I'll try to interfere with it. Oh, no, I wanted to figure out how strong this is. So first of all, this is now, it's 0.01 volts. At 10 millivolts. That's possible on an antenna. 10 millivolts. Let's tune the station in. Ooh. So I can't get it with this on. Yeah. Okay. Now we're going to try to interfere with the signal by driving an image signal into the radio. I think I'm going to quiet it right down when we do this. Let's try this guy. That's better. It's going to be like 1500, I think. It's in there. I'll boost it up here. So quite clearly, at this signal strength, padded by this resistor capacitor thing a little bit, an image up at this frequency is interfering with the signal we're listening to. $15.95. We need to find an example where there's an actual noise signal high up in the band and then look for it as an image lower down. So we're going to tune up here until I find something. And something strong. Oh, that was strong. How do you know strong? Tricky. I think there's a signal there, and that's why it's quieter than there. Okay, let's try this. I want to be sure about things, so I'm gonna, yeah, as sure as I can be. By the way, the radio's working. I guess changing that capacitor did the trick. Let's look on the SDR and see what kind of noise signals are available in my shop. So up in this range, there's a bunch of them. And we'll listen to them. You don't necessarily need this to be a modulated noise signal. So there's a strong signal, there's almost no sound. And that's at 1425. There's no sound though. How would you know this is interfering? You generate a heterodyne. That's how. 1425. So let's try this. We can what? We can wave my antenna around and see if that signal. It's not behaving like the rest. I think there's a better one. Oops, didn't want to do that. Right there. Okay, so there's a better noise signal there. That's at 1466. By waving the antenna around, it goes up and down. That other one didn't seem to react. So I'm sure that's a signal here in my shop. Now I want to tune the other radio exactly to 1466. Tune the other radio exactly to 1466. Now, the only reason I'm doing this is to see what it sounds like at 1466. The signal generator is set to 14, so we should find it. Okay, so this will be 1466 right in here. You can hear the noise underneath it. Now I'm going to tune off 1466 here. Nope, I don't hear any noise. Well, I don't know what to think. Let's try this a different way. I'll set up an image signal. I'll try to find it down here. Yeah, okay, I won't explain everything I'm doing until I'm doing it. So we're going to we want to what? Yeah. The reason I'm not going to explain it is because I can't explain what I'm doing. I don't know what I'm doing. Pick up some big ugly noise signal here. Okay, we'll just pick one. Pick that. That's occurring at what happened? There you are. Almost 1600. $15.95. So $15.95. Go down 455. $15.95. $11.50. $11.40. $11.40. So I think the local oscillator is at $11.40. Let's see if this is true. $11.40. Let's look on the SDR again. So $11.40. Ooh, I don't see much there. Be right around here. 11. That's not 11.40. 11.40 is down here. 11.40. Wow, it's empty in there. Oh my God, my radio's breaking down again. Ah! Ah! Oh my gosh. Okay, equipment off. I thought I had it. Radio up. Magic stick in hand. The noisemaker's gone. What are we hearing? Yeah, it's the same problem. No volume, still hear it. But I didn't get it with that capacitor. I got something with that capacitor. Another one. So I see a capacitor with a bulb of wax on the top of it. That's kind of weird looking, and it's this one. Oh, where'd the noise go? I was all excited there. Okay, there's a resistor in behind there too. I don't think so. Okay. I have to revert to a thinner stick. So I'm going to get in and try to kind of... Oh yeah, there's something going on there for sure. Now what is it? Yes, Peanut. Okay, so it seems to me over and over and over, this capacitor down in here is a bad actor. He's hooked up to this terminal and hooked up to some other terminal way down here. Where's it there? I think it's hooked up here. The lead wire is so hidden. Oh, there it goes. Okay, I see it now. Over to here, over to this terminal. So it's from here to here, through there. And like I said, I don't know if you can see it in the camera. Yeah, you can. There's a funny little bulb of wax on it here. Kind of a weird looking thing. It should look like this. See how nice that is? And this one, and this one, they're all nice. See, this one's not too bad either. That guy's got a funny bulb on it. Okay, let's cut them out of there. Now, some of you no doubt are saying, just change them all, just change them all. Well, you know, that's time and money and effort. Yeah, my cat wants me to spend time with him. So in a world where there's more than one thing to do, I don't think I got it. You may not want to spend all your time changing capacitors. That didn't sound good. What fell in this radio just now? Is that a chunk of solder? No? Yeah. No, I lost it in there. Okay. I'm not gonna... That's it. Okay. Now, before I forget entirely what I'm up to. So we want to remove that capacitor, which I've already cut. There we are. Well, yeah, it doesn't look that bad. Another 0.01. Outside foil down. Yes, Peanut. What is it, buddy? He wants some attention. Well, we all want attention. So I'm gonna, I'll install the new capacitor, but first I gotta go play with my cat. Okay, let's solder this new guy in here. There he goes. Okay. Now we'll get the other end. Oops. There we go. Very good. Okay, so is that the guy who caused the problem? I don't know. Let's put him in the tester. We'll find out. This will be the fourth capacitor to check from this radio. There we go. Okay, 50 volts. What do you do? Opens right up. 150, not opening at all. So not same as the others, basically. Somewhat leaky. A little more than the last one. Leaky isn't going to cause pops, I don't think. So maybe it's breaking down inside too. You know, we can push this capacitor here. Let's do that. Let's push it. 150. Well, if it breaks down while I'm doing this, I'm not sure what my machine does, to be honest with you. 350 volts. Ooh. I heard something in my speaker here. Let me put the headphones on. Maybe you're listening to stuff I'm not hearing. Let's see. Okay, I'm going back a chunk. Nothing there. Oh yeah. A little pop in the speakers. But I don't think it's because the capacitor's bad. I think it's just my machine working at higher voltages. I don't think that's anything there. Hard to say. Oh, another thing I can do another thing. is a little bit bogus here. Could be the where the leads coming out are making contact on the foils has gone bad. And if I do this, let's put it to 50, and do this kind of thing. No, nothing happened. Just seems like a little bit of a leaky capacitor. Oh my gosh, did I get the one that's causing the problem in this radio? I don't know. I don't know, but I seem to be going one by one, replacing these guys. Let's set it down and get back to what we're trying to do. I can hardly remember what I was trying to do. Trying to have fun with this radio, that's the primary thing. Trying to have some fun here. Nothing like a little bit of fun. Got a major cord tangle up here behind the scenes. Just untangling myself. Okay, switch it on and make sure it's working. All working. Let's see, signal generator running at 1562. Where is that? There it is. Sounds very good. Now get back to the image deal. I've got a signal going into the antenna, very loud, very strong. Why so weak? Well, it's not all that weak. Okay, can we pick up this tone down yonder? Not like that. Attach the ground to the chassis. It's at 50, so here we are, it's going 590, 600 or so. 1510 on the signal generator. Should lots of noise from that soldering iron. 1510. There it is. So we have a very strong image signal being applied to the radio. Now if I quiet down that image signal at all, it pretty much disappears. I'm going to tune the radio a bit. Okay, so now we're going to tune in 590. It's about now when the radio starts breaking down. Can that signal interfere with this? So, okay, I'm going to make a comment at this point. I mean, the answer is yes. A strong signal at the image location up here can appear in the radio. Just check this out. Can you hear the tone very clearly? That's not modulation, that's interference. Now if I was listening to this radio and I just tuned through like this, the station I want has this tone on top of it. But you and I know where it's really coming from. It's coming from up here. Now all the time I'm tuning these radios and I hear stuff like this. So if there's, now listen again. Now do you hear there's a tone there, a higher pitched tone? As I tune the radio, the pitch doesn't change. But on that other one, the one from the signal generator, the pitch changes. So I think the difference there is, in one case, the interfering signal is right here. And so we have the signal we're trying to tune in, and then we have another signal really close to it, say within 5 kilohertz. And we tune them with the tuner. We get them both. They both head through the mixer tube. The next thing you know, the difference frequency is available. 1,000 hertz. I probably don't have that story quite right. But the point is, never mind about my story about it. The point is, the interfering signal, if it's right next to the one you're after, the heterodyne difference won't change as you tune. So why would the other one change? I have to think about that for a while. Why is it this one has a pitch rise in it? So I think here's the point I'm getting out of this. Do you hear this kind of thing in a radio? Probably an image on top of the signal you're chasing. I guess you could even have situations where as you're tuning past noise signals, other noise signals are adding in, and maybe you're getting that a little bit. Let's tune around here and see what we hear in terms of this rising and falling pitch, if anything. No, I'm not counting that one. Only that one. Okay, let's do this. Let's take it off the signal generator entirely. Let's boost up the antenna by applying the outdoor antenna here. So I'm just going to do this. To get the heterodyne, you need 2 signals. You can't do this where there's no signal at all. So what we're looking for is the shoo sound. Oh, that's got a steady. It's not a nice clear tone because it's not a nice clear sine wave that's interfering. It's an ugly, noisy signal, giving that kind of a warbly sound to it. So what I'm trying to do here is teach myself how to recognize these sounds. So when I play a radio, I know just from listening to it that, oh, it's got image problems or whatever it might be. Radio's working pretty good, I'll say that much. I don't hear any of those rising tone type interferences, but I have heard them on other radios. So it could be the case that there is no image interference going on in this radio right here in my shop right now as I tune across the band. That the noise signals that are up here in the danger zone are suppressed enough that when you pick something up over here, they just don't count. The signal I'm sending from my signal generator is way higher than anything you would normally encounter. And that's why you can bring out these things that are occurring, which may in the end not have any meaning for the radio we're actually using right now, because it's working properly. And of course, this is what radio designers are trying to design out. They're trying to design out problems like this. So we should not be surprised, even though the front end of this radio is really crummy. So in short, with this radio, it takes quite a high signal to drive the image signal out of the speakers, so to speak. So to speak. What if we try a radio with an extra tube in the front and do exactly the same thing and see if in fact it also picks up this image signal, or if in fact it doesn't. And the fact is, the last radio I had in here, a clock radio, I accidentally ended that project prematurely. I was in a bit of a rush. It's got to come back in here because I didn't put the bottom plate on it. That's the number one thing, of course. And number two, I never quite finished the alignment on it. And C, it has an extra front end tube. So we can have it in here even with this radio. We can do the two of them at the same time, do all this image experimenting, and find out if that extra tube really does knock out interfering images. The extra tube's going to increase the sensitivity of the radio tube generally. Great. I'll go get that radio, I guess. Where are we? I don't know where we are on the clock here. I think I'm about a half an hour into this video, so I'll go get the radio and we'll set it up. And here's the radio I've got to take apart again, because here's the bottom plate I left off a bit. So, okay. So let me get this out of the cabinet and set up for some experimenting, including the alignment. The phase of the alignment that I missed with this radio was just doing the oscillator and getting the pointer correct. But nevertheless, there's a nice radio. Okay, let's get it apart. Now let's see if I can get this out and leave it plugged into the clock. The answer is yes. There we go. So, this radio we're listening to in the back here, the antenna basically is attached essentially to the grid of the mixer tube. In this radio, the antenna is essentially attached to the grid of a pre-selector tube. There's tuning basically on either side of that tube, if you like. And then the signal makes it to the mixer tube. So one of the ways you can recognize this difference between these radios right away is that, oh, don't fall over. Weird. So in the radio right below, just one sec here, you see 3 capacitor sections. Okay, 1 small and 2 that look the same. But on the other radio, when you look at its capacitor, it's only got 2 sections. 1 small and 1 that looks kind of like these ones, in fact, size-wise. So it's oscillator. Very front end is probably this guy. You can see the antenna connection to it. Goes through the tube, comes out, goes through another tuning. Hey, that doesn't make sense. Hey, that's not true. Okay, so what tube is this? Okay, so I got this a little bit wrong. Not completely wrong. Oop. 12BA6. Okay, so this is just an amplifier tube. Oh, that's right, I remember now. I got confused. I saw this can and thought this is an IF can. It's not. This is an RF can. So yeah, so antenna to here, tuning. Through the tube, boosted. Into here, tuning against this. Into here for mixing. So it's got this whole front end here that's missing in the other radio. And then on top of that, it still has a coil antenna that is also part of the tuning system, the tuning with this capacitor. So conceivably, this guy is less sensitive to images. That's the whole deal. Now, let's get this radio playing. I'm only going to run one radio at a time here. For now. Okay. There we go. That hissy sound is the clock motor running. That's what you're hearing there. So we're going to do exactly the same test with this right away. We're going to tune this to 600 and see if at 1510 we don't have an image. So 600. Okay, so to get 600 for sure, I need the output here. Bring this around near the antenna. Yeah, just leave it like that, it might be enough. Maybe over here. Okay, let's change some lighting. Change some more lighting. There we are. So we want this on 600 exactly. Now, normally you hear a tone in my shop, but I'm not modulating this. I'm still not hearing it. There it is. So we're at 630, but we really want to be at 600. So we'll tune this way a bit. Let's put this on 600. We're using 600 primarily because I calculated it already on 600. That's why. 600. Okay, now we'll okay, that's about dead on there. So the radio's at 600. Now, can it hear 1500? Now, before, I actually attached the signal generator right to the antenna input of that other radio to make this thing show up. But let's try it like this, just with the leads kind of drooped over the antenna here. 1500. So I didn't hear that at all. 1510 is where we would expect it. Nothing. So now I'm going to attach the output of the signal generator right onto an antenna lead, but not attach the ground to anything. Wow, sound like it retuned the radio. There it is. It's much weaker. The way I can boost it even stronger is by hooking up the ground from the signal generator onto the chassis here. Don't do that. Yeah, okay. So this really has to connect, I think, to the B- point inside the radio. I can't do it like this right now. So it is sensitive a little bit. I'm trying to think of what to try next. So comparatively, that radio is more sensitive than this one. I'm surprised that this one reacted at all to it. Okay. So I think that's about as far as we're going to get with this whole deal. I think that's far enough too. I think I got a lot out of this. Certainly there is it's worth doing a test to see how strong the image is coming in on a radio like this. I've never done that before till today. Obviously there's ways of highlighting the strength of the image signal. I'm using that word image now because it's so convenient. And I think from now on I'll probably do some kind of image check on each radio that I work on. I keep my ears peeled for a radio that has that varying pitch interference, because I think that says that's an image coming through on top of the signal you're trying to tune. And before I put this one all back together, I will put the bottom plate on it and I will correct the oscillator on it. So, okay, well, thanks for watching. Hope you got something out of this, and I think I'm going to be, well, I got to put this radio back together yet, and that's what's left.